Hello my friends and welcome to this quick revision in your favorite subject, chemistry. Today we are going to carry on talking about the same topic, types of ions, and we are going to answer a question that is related to this topic. Before I start answering this question, allow me to give you a quick revision for what we have taken so far about this topic. We started talking about the definition of ion again, and we said an ion could be one atom or more or a group of atoms that have a charge. Then we talked about monoatomic ions, and we said that generally a monoatomic ion was a neutral atom which has two main parts. The first one, which is called the nucleus, including positive protons and neutral neutrons, and then it has the other part, which is called the electronic shells or energy levels, which includes electrons distributed on those shells or levels. Today our topic is going to be related only to the monoatomic ions, and then we said that a monoatomic ion is an atom that either has lost one or more electrons to be positively charged during the prominence of the positive charge, or gained one or more electrons to be negatively charged because the number of electrons this time is going to be higher than the number of electrons, and the atom, or which was an atom, became a negatively charged anion or negative ion. Now, my friends, let's answer the question of this class. Before I answer this question, I would like to advise every student to go back to class number 7 and replay the video talking about the electronic configuration, because in this class we will need the understanding of this concept crucially. And without understanding this concept specifically, we cannot understand this class. So please go back to the playlist and try to rewatch the class number 7 and understand the electronic configuration. Now, my friends, let's answer the question. The question is, why do some atoms like sodium, Na, potassium, K, or silver, Ag, they lose only one electron to become charged with +1, like sodium here, potassium, and silver, while other atoms like magnesium, calcium, barium, etc. lose 2 electrons to become positively charged with +2, like magnesium +2, calcium +2, and barium +2. Finally, and others like aluminum and chrome lose 3 electrons to become aluminum +3, chrome +3. Now let's take the sodium, potassium, and silver to discuss this matter. Well, we all know that the sodium has the atomic number 11, which means that there are 11 positive protons inside its nucleus and 11 electrons in the electronic shells. Now, as we all know, shell number 1, which is called K, can take only 2 electrons here. The other one, or the second one, L, can take, yes, 8 electrons. Now, 2 and 8, 10. We still have 1 electron in M. And now, as you remember, we call the last shell, which is filled at least with 1 electron, we call it what? Yes, the valence shell. The valence shell. So the valence shell here has only 1 electron. And generally, we all know that all of the atoms in the world tend to have a full valence shell. The problem is that here, for sodium has 2 options. The first option is to gain 7 electrons and becomes Na7 minus, or to lose 1 electron and becomes Na plus. So if the sodium atom gains 7 electrons, is going to be positively charged with -7, and the last shell or the valence shell is going to be full, and the sodium atom is going to be happy. The problem is that this requires a lot of energy. While losing 1 electron only here will make the valence shell L. Again, losing the electron which is in M orbit will make the last shell with electrons L. So how many electrons in the last shell or the valence shell? 2, 4, 6, 8, and now the atom has 8 electrons in its last shell, and it's going to be stable. That's why sodium prefers to lose 1 electron to have its last shell full, better than gaining 7 electrons, which requires a lot of energy. Let's take another example about the potassium. Well, for potassium, as we all know, potassium has the atomic number 19. And if we take the electronic configuration of the potassium atom, we are going to see that the first shell takes 2 electrons, which stay here and stays 17. Another shell takes 8, the second one L. Now we have 10, and there are 9 to be distributed. The last one, or the third one, takes 8 also. We still have 1 electron here in KLMN, in N shell. As you see, again, my friends, 2 electrons here in L, in K, 8 in L, 8 in M, and 1 in N. So the last shell or the valence shell is called N shell. Here, potassium has 2 possibilities. The first one is to lose 1 electron to become positively 1 charged, this way. If potassium lost 1 electron, it would be positively charged 1, and the last shell or the valence shell is not going to be N anymore. It's going to be M, according to the definition of the valence shell, which is the last the last shell filled with electrons. Now, the other option is that here the potassium gains 7 electrons. Here 1 new electron, 2, 3, 4, 5, 6, 7, and potassium is going to be -7, which is impossible. My friends, it's way easier for potassium to lose only 1 electron than to take 8 electrons, 7 electrons to become -7. That's why you see all of the atoms that have in their last shell 3 electrons or less, they prefer to lose those electrons better than gaining 5 or 6 or 7 electrons to make their last or valence shells full. The same thing applies for aluminum, which has 3 electrons in its last shell or valence shell, which prefers also, like a chrome, prefer to lose those 3 electrons and becomes +3 rather than getting or gaining 5 extra electrons to be charged -5. Well, that's it for today, my friends. I hope you enjoyed this class, and if you don't understand any point of it, please try to replay this video again and again. I recommend watching video number 7, which talks about electronic configuration, for better understanding to this topic. Today we cannot carry on talking about the monoatomic anions because the video is going to be very long. Watch the next video, which is going to be talking about this topic. Thank you again, my friends. See you in the next class, and I hope you have enjoyed and learned something in this video.